In this lesson, I'll show you how to separate fractions into partial fractions. This is question number 4. Unlike in questions 1, 2, and 3, here we have to deal with a fraction whose denominator has one quadratic factor in addition to a linear factor. Take a look. We have x to the power of 3 plus 3x squared minus x. If we go ahead and factor this, let's say we common factor an x from each of these terms, we end up with x times x to the power of 2 plus 3x minus 1. Notice that we have this factor, which is linear, x is linear, and we have x to the power of 2 plus 3x minus 1, which is quadratic. And unfortunately, we can't factor that further. When it comes to making partial fractions, you have to rewrite your function in terms of its factors. And for each factor that you have, you'll create a fraction from that. So we have x as our denominator for our first fraction, and for our second fraction it has to be x squared plus 3x minus 1. I'll introduce an unknown letter that will represent my numerator, a. Unlike before where I would put b, I have to write down bx plus c. And you will actually do this whenever you have a quadratic factor. So let's go ahead and find out what a, b, and c is equal to. I'll start by finding a common denominator, and I can do that by multiplying this x with the following expression. We should end up with this. Then I'll cross multiply the denominator with the opposite numerator, giving me ax squared plus 3xa minus a. And then this multiplied to these, I end up with plus bx squared plus cx, our common denominator being x to the power of 3 plus 3x squared minus x. Now I would like you to pretend for a moment that I multiplied both sides by the denominator shown here. I would end up with this canceling out with this, leaving me only with the numerator up here and the numerator on the right side. Let's write that down. X plus 2 is equal to everything I wrote up here. Now that I've written down my expression, I have to find out what a, b, and c is equal to. What I'll do is collect like terms, and I'll highlight them. So this term is alike with the only other x squared term. This term is alike with this term and this term. All three of these have an x. And this term is alike with this term. Both of these terms do not have a variable. Let's write that down. We have 2 is equal to negative a, and therefore a has to equal to negative 2. Let's write down what we have in yellow. We don't have anything on the left side, but we do have a plus b. I don't have to write down x squared because they'll cancel out anyway. And now the factors that are underlined, we have 1 is equal to 3a plus c. So I'll take this negative 2, place it right here, and then solve for b. That gives us negative 2, bringing it over, positive. b is equal to positive 2. And now to find c, I'll take this negative 2, place it into there. That gives us negative 6, bringing that negative 6 over, makes it positive 6. Therefore c is equal to 7. I just found out the numerators of my partial fractions. So I'll substitute what I found for a into here, which was negative 2. Substituting what I found for b, which was 7, into here, gives me 7x. And substituting negative 2 into here gives me 7x minus 2. And over here, negative 2 over x. And so there you have it. That is how to separate fractions into partial fractions.